So this is going to be the last section of the second half of chapter 2, and we're going to be talking about the quadratic formula. And I mentioned yesterday that the quadratic formula is really nice because it works for any situation. There are some quadratics that it is easier to just factor, or it's easier to use the complete in the square method, or sometimes it's easier to graph. The really nice thing about the quadratic is if you're unsure, or if it's something that's not easy to factor and you're not quite sure if you want to try to do complete in the square, quadratic will work every single time. It's always the one that you can fall back on, and it's probably like the most used because it's useful for any type of quadratic equation. So in order to solve a quadratic, so far we've talked about graphing, factoring, completing the square, and now we're going to add in a fourth method, which is the quadratic formula. So your quadratic formula looks like this. So I have this chart in here. It's this big equation right here. Once you know this equation, all you need to be able to do is look at your quadratic equation, figure out what's A, what's B, and what's C, which hopefully we've been doing that enough that you hopefully know where A, B, and C are in the quadratic equation. And you just plug them in to this quadratic formula, simplify it, and solve it. There are ways to help you guys remember this equation because it is a longer one. There's songs that kind of you can sing to yourself in your head. I know that I learned the quadratic formula song when I was in high school, and I still remember it from then. So it is useful to have that, which we can talk about that later. I'm not going to sing it to you guys right now since I'm recording, but what we could do later is go back and kind of talk about that because it is a useful way to help you remember the order of the quadratic formula since it's a bigger formula. But basically what you're going to do is you're going to do the opposite of b, plus or minus the square root, and then you do b squared minus 4ac. So that's just plugging in a, b, and c there, and those numbers 4 is always going to stay there, all over 2 times a. So it always looks like this. Once you know it and once you have it in your head, you can always just plug in those values. They give an example here in this chart of a quadratic equation, and then they show you how to plug those things in. So if they're asking you to find the zeros, we're going to practice using the quadratic formula here. So I have x squared plus 3x minus 7. So if I go first and I identify my A, my B, and my C, A is the number in front of your x squared term, so this one doesn't have a number written there, so it's technically a 1. B is going to be your 3. C is going to be the number at the very end, which is negative 7. Okay, so quadratic formula says that you're doing opposite of B, plus or minus the square root, b squared minus 4ac, all over 2a. So using what I just wrote over here, let's plug in a, b, and c now to my formula. So negative b, or I've been saying opposite of b, you're just changing the sign. So if it's positive, like this one has positive 3, you're going to put in a negative 3. If it was negative, then it would change to positive because you'd have a double negative there. Plus or minus, square root sign, and then we have 3 squared minus 4. In for A, you're going to put a 1. In for C, you're going to put a negative 7. So all of that's contained underneath that square root sign. And then this is all over 2 times 1. So what I do next is just try to simplify piece by piece. So don't try to do too much at one time because that's how mistakes can happen. I'm going to focus on underneath the square root portion, and then I'll also simplify the denominator of this fraction. So I've got negative 3 plus or minus. Now underneath the square root, 3 squared is a 9. Minus, if I take 4 times 1 times negative 7, that's going to be negative 28. All over 2 times 1 is 2. Now under my square root sign, I have double negatives. I have 9 minus negative 28, so that's going to change to a plus sign if you do your keep, change rule there. So I have negative 3 plus or minus 9 plus 28 is going to be 37 all over a 2. Now when you get to this point, because we have a square root, you will have to figure out if you want to reduce it if you can. So for 37, it's not a perfect square number. And if I think about my perfect square numbers, 4, 9, 16, 25, and 36, because 49 is going to be too big, none of those go into 37 very nicely. 37 is actually a prime number. So it's not going to have any factors other than 1 and 37. So I'm not going to be able to do anything here, so I'm just going to go ahead and box it up and keep it in that form. So with the quadratic, you will have some cases that your answers look like this, where you can't do anything with that square root, or even if you could, you would reduce the square root as much as you can, and then you'd end up leaving it. You will have some cases where you get really nice numbers to come out, like nice whole numbers, like a 2 and a 3. You will have some imaginary numbers show up, so we'll see that too. And there's also going to be cases when you do your quadratic that only one number comes out, that you don't necessarily get 2, because again, we talked about all those cases of those quadratics, of how it can cross on the graph. It can cross twice, it can cross one time or no times at all, and how that talked about 2 solutions, 1 solution, and then 2 complex. Let's look at another one together here. So x squared plus 12x plus 20. Can you guys tell me what's A, B, and C? What number is your A? 1. B is A, and C is 20. Okay, so we're going to start with opposite of B, so negative 12 plus or minus. Big square root here. Underneath the square root you have b squared, so that's your 12 squared, minus 4 times a, which is 1, times c, which is 20. All over 2 times a, 2 times 1. So let's simplify a little bit here. We've got negative 12 plus or minus. 12 squared is 144. And then if I do 4 times 1 times 20, that's 80. So I have 144 minus 80 all over 2. So underneath the square root, if I take 144 and I subtract 80, I'm left with 64. Still all over a 2. Now what's the square root of 64? 8. So I have negative 12 plus or minus 8 all over 2. Because we still have that plus or minus sign happening, there's 2 answers here, so you have to do both of them. So the first one that you need to do is the negative 12 plus 8 and divide by 2. That's going to be one answer. Then you need to do negative 12 minus 8 and divide by 2. That's going to be our second answer. These ones should come out as nice numbers. So if I take negative 12 plus 8, that's negative 4, divided by 2 is going to give me negative 2. So there's one answer. If I take negative 12 minus 8, that's negative 20. Divided by 2 is going to be negative 10. So there's my second answer. So negative 2 and negative 10. Now like this one, if I come back and just look at the problem, I probably could have factored that instead of using the quadratic if I wanted to, because the 2 numbers that would multiply to 20 and add to 12 would be negative 10 and negative 2. So I could have used factoring if I wanted to, but like I said, this is just showing you guys the multiple ways that you can use the quadratic and kind of see how it works. Now on number 3, so on the next page, because there's a 2 sitting in front of the x squared, this is one of those cases that you could factor by doing the long way of factoring, but that's not always ideal. Because that method's, I mean, it works, but it's not always the favored method. So that's why quadratic is out there too for us. So again, let's identify A, B, and C. So what's your A for this problem? B, -2, and C, 3. Okay? Take a minute and try to plug in those values into your equation. You don't have to solve it, I just want you to try to plug in the pieces yet. Okay, so to plug it in, you're going to do opposite of B. So this is going to actually take that -2 and make it become positive. Because if you do the negative of -2, that's going to end up being a +2. So if you want to go ahead and just write it as a +2 right away, you can. Plus or minus big square root here. So we have b squared -2 squared. Now, when I have a negative in for b, I put parentheses around it to just make sure, like if you're typing it in on your calculator, because some students will do that they'll just type in underneath the square root on their calculator to get the number. You're going to want to make sure that you tell your calculator to square the negative and not put a negative in front of the number squared. Otherwise, it'll mess up the end result. Then -4, a is a 2, c is a 3. All over 2 times a, 2 times 2. Okay, so make sure that yours matches mine. Now I'm going to do some simplifying. So I have 2 plus or minus, -2 squared is +4, minus 4 times 2 times 3 would be 24, all over 4. Now if you got to this point, you may notice that underneath the square root sign, we're going to get a negative number. So for this answer, we're going to have to deal with the complex number. We're going to have an I involved in this one, like we were dealing with in the previous section. So I have 2 plus or minus the square root of -20 all over 4. Now I got to take care of that square root. So the first thing I'm going to do is pull out the I to go ahead and just get rid of that. Now I'm thinking about +20. What's the perfect square number that goes into 20? 4. So 4 times 5 is how I'm going to rewrite that 20. So the square root of 4 is going to be a 2. So make sure that when you square root the 4 here and you've got your 2, that pops out in front of the square root sign. So you have 2 plus or minus 2i square root of 5 all over 4. Now yesterday, I think it was yesterday or maybe it was 2 days ago now, when we talked about square roots. Like we had a problem that the answer was the square root of 6 over 6. And I said, don't try to simplify the 6's. Because one's underneath the square root and one's not. For this problem though, you guys see the 2, this 2, and the 4? Those are all outside of the square roots. Those are just plain numbers. What's a number that could go into all 3 of those? 2. So I'm going to reduce it by taking a 2 out of all of those numbers. Not the square root, just the numbers that are sitting in front. So if I divide all of these by 2, oops. All right, so if I divide all of these, oh my goodness. This thing is having an attitude problem. Okay. And of course it's doing it on the class that I'm recording live. So whoever gets to watch this at home gets to see all this. Okay, divide everything by 2, so we end up with 1 plus or minus. It'd be 1i, or you could just write I, square root of 5, all over 2. And this is where you can leave your final answer. So the only time you can reduce like that is if the numbers are not underneath the square root sign. So if you're pulling anything out, and you've got these numbers sitting outside, like the whole numbers, you can then reduce it if they have anything in common. All right, so we've got a couple more that I want us to get through today. So if we look at number 4, you've got x squared plus 6x plus 9. Now if I was thinking about like trying to factor this, what are 2 numbers that would multiply to 9 and add to a 6? 3 and 3. It's the same number twice. So if we think about that, it would be x plus 3, x plus 3. Now if I set those equal to 0, I'm going to get negative 3 because I would subtract the 3 over. Now because they're the same number twice, this is one of those cases where you do have 2 solutions, they just happen to be the exact same thing. So when we do our quadratic here, we should already be able to know that the answer is going to be negative 3. And we're only going to get one of them because you're going to end up getting the same number twice. So let me show you what happens here when you're using the quadratic. So your a for this one is a 1, your b is a 6, your c is a 9. So we're going to do opposite of b, so negative 6 plus or minus the square root. B squared would be 6 squared minus 4 times 1 times 9 all over 2a. Oops, all over 2 times 1. So negative 6 plus or minus, what is 6 squared? 36 minus, what's 4 times 1 times 9? 36. All over 2. What's going to happen underneath my square root sign? It's going to be 0. Okay, so when this happens, you've got negative 6 plus or minus the square root of 0, which is a 0, because 0 times 0 is 0. So basically, this is going to go away, and you're going to be left with negative 6 over a 2, which is negative 3. And that's how you get the 1 number. So if you have a problem like that, the 0 should always appear underneath the square root sign if it's that same number 2 times. All right, last one that we're going to do for today. What is missing in this equation? B. There's no x term. So your A is going to be a 2. Your B is going to be a 0. C is going to be negative 19. So when I use my equation, I do opposite of B, which would be trying to do like negative 0, which isn't a thing. So it's just 0 plus or minus. Under the square root, we have b squared, so 0 squared, minus 4 times ac, so 4 times 2 times negative 19, all over 2 times a, 2 times 2. Now, underneath the square root sign, because we've got 0 plus or minus, we've got a 0 squared, which is 0, and then minus, if I take 4 times 2 times negative 19, that's going to be negative 152. So we've got the double negative happening again here. So this is going to end up adding, so it's going to be 0 plus 152. And that's all over 4. So what I'm going to do next is kind of start to drop these zeros off because they're not going to affect my problem at all. So I'm going to be left with the square root of 152 over 4. Now with the 152, we want to try to see if we can reduce it at all. So we want to see if we can find a perfect square. The only one that goes into 152 is a 4. Well, and let's not forget our plus minus sign sitting in front. So we're going to have plus or minus. It's 4 times 38. All over 4. What's the square root of 4? 2. So this 4 becomes a 2 that pops out front. So now I have plus or minus 2 square root of 38 all over 4. What's the last thing I should be able to do here? Good. See the 2, see the 4. I can take a 2 out of both. And so I'm left with plus or minus square root of 38 all over a 2.